Hello, internets. Welcome back to the LARVOL Onco Data Podcast. Hopefully your favorite Friday afternoon podcast to learn about some of the things we're doing at LARVOL in oncology data, in the public sphere, and the interesting things you can do with that data. So to that end, we're actually going to talk about some very interesting things you can do with digitized outcomes data in oncology. So you might recognize his face either from looking just like Edward Norton or just looking just like himself. So thanks, Darko, for rejoining me. And for the uninitiated, wouldn't you mind reintroducing yourself, Darko?
Thank you so much, Mark. You always do the best ever introduction for me, and always great to be your guest. Just a small reintroduction. My name is Darko Medin. So I'm a biostatistician, a friend of LARVOL, someone who is also in digital product and artificial intelligence space, and that's a very short recap. And I'm someone who works in the field of developing digital biostatistics and artificial intelligence products, and some of those projects are actually related to LARVOL. So that's it from me for a short intro, and I leave it to Mark to actually continue with some very interesting, I think, topics that we will be discussing today.
Absolutely. Well, Darko's obviously a friend of LARVOL, but as you'll see today, not only is he a friend, we put him to work, and he's a member of the team as well. So today we'll be introducing on the CLIN platform itself two key new elements that we've been working on, with Darko playing a big role. So I'll maybe set it up verbally, but Darko will be giving a demo of the two things we wanted to sort of rapid fire introduce today. And we may have talked about it, Darko, broadly or verbally on prior podcasts. But A, there's pseudo-IPD, and B, there's network meta-analysis. So I think I'll just to sort of verbally introduce, with pseudo-IPD, meaning pseudo individual patient data, the CLIN platform works completely from public data. So we do not work from patient data. We do not try to access patient data. Our job is pulling together everything that's in the public domain, whether it's from publications, conference disclosures, everything that's out in the public domain, and digitizing that data. So one sort of key element of that is we do broad scale extraction and digitization of what's publicly available in terms of KM curves or survival curves. So that's an element that's visualized in the CLIN platform and used by a lot of our customers to look at trials. But then another element that we've made a lot of progress recently is also having the at-risk data, or at-risk tables as they're commonly represented in publications. And we got a biostatistics friend, Darko here, who helped us put the software together to combine those two elements, the curves and that at-risk data, that you can combine to basically, the way I describe it, is a time to event data set, which is how I describe what pseudo-IPD means. And the simplest premise is you can look at even different experimental arms that are comparable or complementary, different control arms, and put those populations together to sort of have a synthetic look at how populations might behave. So with that rather non-scientific and sort of a flowing description of things, I might yield back to Darko, who's sharing his screen. Maybe I think we want to look maybe at some melanoma data to sort of demonstrate on CLIN. And this is live on the platform, an example of what that pseudo-IPD type of synthesis looks like. So Darko, I'll yield back. Like I say, let the smart people do the smart things. So Darko, would you mind showing us this live on CLIN?
Thank you so much, Mark. It's really a great project, and I think you explained the most important parts, which is being able to reconstruct data from large number of trials and published data, published curves, published and a number of risk data within those trials, and create a common data model that we will be now showcasing through the Pseudo-IPD module on LARVOL platform. Now you can see that it's actually a button to the right. So whoever visits CLIN LARVOL website, there is a new module, Pseudo-IPD, which is now in beta version. So we are, it's functional at the moment, but we are still improving it as the time goes by. So as Mark said, I will be discussing one example of how this would work when actually implemented on the platform and what's actually behind this data. So for our audience, they may be seeing reconstructed curves, they may be seeing a lot of visualizations and so on. It's very important to understand that behind all these is very large data set of reconstructed common data oncology survival model. So seems like a very complex set of words, but let me show for the audience how that would work. So in the Pseudo-IPD module, there are several options at the initial interface, and we can filter the trials, make selections, select multiple trials, multiple different treatments potentially, but it's very important to select them for a very specific condition. So in this case, I can search for melanoma. I already have it here in the recent searches, and show results. So this is one big advantage of having a large common data model. You can see now that the LARVOL platform actually found 116 trials, which we can use to pool the data, to combine the data, and create actual curve. See actual patterns, how survival is being reconstructed from those trials. Then the second part is it's very important to also use additional filters that we have here. So when I click more filters, I can try to use similar stages of condition of, in this case, melanoma. So I can filter stage 3, for example. It's very important to make these pooled curves from a comparable set of characteristics for that specific disease. So I'm going to show these trials now. And we can also use additional modalities. So we can use, for example, PD1 and PDL1, right? Mechanism of actions. That's another very interesting feature, that we can try to focus on a specific mechanism for specific drugs when pulling the survival curves. And we can now see that 28 trials are now found, and we can see the trials here. So we have the Checkmate, Keynote, Inspire, and so on. So we can see what's actually within these curves. It's important to, again, make comparable endpoints, comparable outcomes. So I can choose nivolumab from the Checkmate trial. Then I can go to the next trial, and I can see here that it's also overall survival. So I'm using the same endpoint. I can now choose ipilimumab, and so on. I can select multiple. Now we can see that here we have recurrence-free trial. So it wouldn't be logical to combine recurrence-free survival with the overall survival. So I'll be looking for overall survival to add additional studies. I have it here. I have another Nivo trial, which is the Checkmate 037, and so on. So I can select multiple trials for a specific mechanism of action, for a specific type of disease, such as melanoma in this case, and I can then combine all those results into one combined survival curve, and that's what we will be demonstrating right now. So there is a button here, Create Pooled Curve, and when I click that, this is the combined survival curve from a common data survival model now. So we can see the shape of the curve. The curve looks slightly different than individual survival curves within trials. It's much smoother because it contains much more data than individual trials. So usually from a few thousand to multiple thousand patients, pseudo reconstructed data actually is contained within these curves. And we can also show the original curves to see, here the trials from which the pooled curve is created and reconstructed from. So again, mentioning one very important thing, this is now reconstructed data, which is trying to be reconstructed as accurately as possible as the real data from these trials. Yes, so that's a very, very concrete demonstration how to use for the use case of melanoma pooled trial for a specific mechanism of action. And I would really invite Mark to provide some comments maybe about this.
Well, I think I'd like to, pretty quickly maybe dovetail over to some network meta-analysis, because I know we only have so much time. But yes, we're really excited about this. As Darko said, it's still in beta, and we're still working on this. And, it sort of relates to, we built tools into CLIN where you could look at different KM curves next to each other and look for patterns. But obviously, there's biostatistical limitations to doing so, just looking visually. So we hope that the Pseudo-IPD and this technology helps move things forward to making, interesting comparisons and making new insights. I guess the next element of it, which maybe we'll only have a minute or two to introduce, is, I guess the common theme would be making comparisons where there aren't direct comparisons necessarily. And that's sort of related to network meta-analysis, where we're pooling all of the data that we can. And I'm putting you on the spot, Darko, in a minute and a half or so, because we have the shortest podcast in the history of podcasts, that this is not live on CLIN yet, but a pretty complex tool that we're excited about to do network meta-analysis of making, direct and indirect comparisons. So it looks like you preloaded, we're changing topics and going fast, but it looks like you may have preloaded some trials, and love to, if you could just get the 60-minute preview, Darko, of the highlights of what we can do here. So I'll stop. That was even too much exposition. So Darko, if you could give me the fourth grade definition of what you've built here, that would be great.
Yeah, so because we have to be wary of time, I preloaded one network meta-analysis, which we already created before. So this is another angle, another module that will be very soon on LARVOL CLIN, where we can actually take number of trials, different types of comparisons, different types of regimens, treatments, and try to create a network meta-analysis where we can infer indirect evidence from the direct evidence that we have. So sort of, if we look at how this network is created, most of the comparisons are versus Keytruda. So that's one of the PD-1, PD-L1 mechanism blockers that we were also discussing previously in those pseudo-IPD examples. And what's very interesting is that we can now make different selections. We can create a specific network where these missing pieces of evidence that were not performed can be inferred as indirect evidence. actually show how a forest plot that would tell us which of these treatment performs best looks like. This is the example. So we can see everything that's to the left that has a smaller hazard ratio is actually a better treatment. So in this case, Yervoy is ranked as the best treatment. And then we can make a comparison, not just for the drugs, but also for combinations of drugs, for regimens. Actually, we can see a lot of pluses here. So there are different combinations. And finally, we can create a rankogram that can tell us, which treatment or regimen is best within that network, is the most likely treatment that will produce the largest treatment effect. So just wary of time, and I did a very quick intro of this. It's something that will be very soon operational as another beta module on Larval. So I'm giving back word to Mark now.
Awesome. Well, thank you, Darko. I put you in a limited time box there, so we might, especially as we move this. Again, it's not on production yet in CLIN. Maybe we'll do another network meta-analysis. We'd love to maybe even do a longer demo. I think that would be fantastic. So, I guess the take-home point from all of this, if you've seen CLIN, if you've found us, on Google, and maybe if you've even signed up for a free trial. You may start seeing some of this, but obviously this is some pretty complex math that goes into it. So we'd certainly hope you reach out to us if you have interest in pseudo-IPD and network meta-analysis. We'd love to meet with you. Anyone listening out there on the interwebs, to show you how this technology works and see how this could support your teams, whether that's in data science or early development or any of those applications within pharma and healthcare. So I always have to conclude with a pitch of CLIN and a pitch of Larval. And most importantly, I need to conclude with a thank you to my friend Darko. Thanks for joining me, Darko. And I hope you have a happy Friday. And I hope everyone listens has a happy Friday as well. Thank you, Darko.
Thank you so much, Mark. It was great as always to be your guest. And really it's special to be part of the team and work together with you and the rest of the Larval team, and looking forward to the next podcast if there is the chance.
I guarantee there's more than a chance. I'll see you soon. Thanks, Darko.